So if you want to connect more than 7 meters shaft, as we have discussed in the last lecture, more than 7 meters, we need to have something, a connecting mechanism. So in your domestic pipeline, in your home, you have always seen one hollow shaft is connected between two solid pipes. The hollow part is called coupling. Very good. That is coupling. So this is the coupling. I hope you understood this drawing. So you have buffer sleeve. This is a hollow shaft, right? And this is the shaft number 1, and this is shaft number 2. We have two shafts that are interconnected using a muff coupling, right? So what happens when you connect, when you put a hollow shaft over the solid shaft? There is flow. When you rotate one shaft, the other shafts rotate or not? Will not rotate, because the diameter here, over here and here is, we are having a transition, there is clearance, so that there is clearance. So we have to arrest that clearance so that if one shaft moves, the other shaft has to rotate. That is when we are introducing something called as right? You all know very well the bullet part, right? Have you gone through bullet part? In the bullet part, there is a bigger wheel and there is a shaft inside there, right? And it is mounted in the hub of the wheel. Just by mounting the wheel into the hub, will it rotate? Will it stand still? No. We have to put something called as key. There is one key part of the The same way, we are in this mob or the wheel and shaft. Okay. So we have the length of the sleeve and we have diameter of the sleeve. These two things you have seen. So what is the design procedure for the same? First we have to go for design for sleeve. Okay. So in that outside diameter is 2 times the diameter plus 13 is the formula, and the length is 3.5 diameter of the shaft. The small d is diameter of the shaft, right? So when you have the power of the shaft transmitted from the columns, you can find the torque transmitted by using this formula, power equal to 2 pi nt by T. So then you have to find the diameter of the shaft. Then you have to check with the steering stress. You have to check with the steering stress. If the induced shear stress is less than the permissible shear stress, then the design of steel is stable. Okay, this is the first point. Second, you have to go for design for key. The small piece you have to design from the thickness of the key. We can take W as width. We have W here as width, and the length is L by 2, that is 3.5 divided by 2. This is the diameter of the shaft. After fixing the length, there are two stresses induced in the key. One is steering stress, another one is pressing stress. So we all recollect all this, what is steering stress and what is pressing stress. Shearing stress is nothing but a stress that is induced in a material by applying equal and opposite forces on the surface of the object. It makes to break or tear of the material. Pressing stress is nothing but it applies a compressive stress on the material so that deformation takes place. Okay, so we have to check for the shear stress using this formula and the pressing stress using formula which has thickness in the formula. If the induced shear stress is less than the permissible, then the design of P is same. Again, the induced pressing stress is less than the permissible pressing stress. The design of P is same. So this is how we design sleeve or moss coupling. Okay, so this is a rigid coupling, and very important part is this is made up of cast iron and it is made up of mild steel. steel or puff is made up of cast iron, that is a brittle material, and knee is made up of mild steel, that is a ductile material. What is brittle material? Will break without information. Okay. So ductile material will break after yielding. That is the major difference. Okay. So let us see few problems in of thought we coupling in the next class. Thank you.